हाय हेलो एवरीवन गुड आफ्टरनून मेरा प्यारा बच्चा लोग टेल मी कैसे हैं सब एंड हाउ आर यू ऑल डूइंग इन दिस वेरी फाइन आफ्टरनून Oh my goodness. I forgot to keep the volume of my phone down and I could listen to the resonance of my voice, isn't it? Okay, so bacha log, tell me kaise hai sab, how are you all doing, how much energy you all have stored for this particular session. I'm so eager to know about all these stuffs. But before that, who is thinking, right, who this person is for them? This is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya, isn't it? And what we're going to do in today's session, we all know the chapter atoms, right? It's a Nannu Munnu Chotu chapter, but still it is so much important. We can expect at least 4 to 5 marks of questions for our term 2 examination from this chapter. Do you want to leave that 5 marks? Obviously not, right? So let's make this chapter so much good, so much confident about this particular chapter by doing as many numericals as possible from this chapter in today's session. So I'm expecting every one of you to be here with me in the session from the beginning till the end, so I can give you one single promise that by the time you move away from this particular class, right, by the time you end this particular class, you will be very thorough with this particular chapter of atoms. So yes bacha log, let's get started. Before that, tell me kaise, how are you all doing, everyone here in this class? जल्दी से जल्दी फटाफट बता दे. ओके, हाउ आर यू ऑल डूइंग? गुड आफ्टरनून गुरप्रीत, कनिका, गुड आफ्टरनून. कैसे है सब? हाउ आर यू ऑल डूइंग? इज एवरीथिंग फाइन? Ready for the session? Ready to start doing numericals as much as possible? Give me some response. Give me that energy from every one of you. How about me? Yes, I'm doing good. Thank you so much for asking. Right? Okay. Anyway, let's proceed with our sessions now. If you want to know more about me, what I was doing in the past, a small introduction about me is being given on the screen here. You can go through it. Okay? More about me, if you want to know more about me personal, right, you can come to my classes regularly. We can chat, we can get to know better, right, to all my students. Moving on. Now, if you don't want to miss any of the live classes happening in our YouTube channel, you can be a part of the Telegram where all the updates are given. So to be a part of the Telegram channel, link is given here and also in the description box. Now moving on, Bugs Bounty. And it's an amazing program which can help you to grab lot much of prizes. What you'll have to do, you just have to go to the description. There you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, you will get so much of prizes, or let's say so many prizes are waiting for you. So don't miss this Bugs Bounty program opportunity. Okay. Now, whoever is new here, let me introduce you to our subscription platform where you can enjoy amazing features and which can help you to get very good marks and ranks for all the upcoming examinations. Okay. We have Plus subscription where you can get access to all the live classes, unlimited access to all the classes, structured courses, and weekly tests will be happening. And if you go for Iconic subscription, you'll get all these features of Plus plus some extra features such as a personal mentor. Matlab someone will be there to guide you. Okay, he'll be there to make all the academic plannings and activities for everything related. You just need to learn. Okay? Then study planners will be given to you weekly, reports will be given to you, special doubt clearing sessions will be there in Iconic. So all those are super amazing features, let's say. Now if you go for 12 months of Plus subscription, it should actually cost you 1,250 rupees. Do you need to pay that much? Bilkul nahi. We have the code of AMB10. Use this, get 10% of discount and maximum offers while you make the subscription. Okay. Now if you go for Iconic, for 12 months, it should cost you 2,333 per month. If you go for the code of AMD10, what will you get? You will get 10% of discount and maximum offers while you make the subscription. Now, bacha log, just share the class to all your friends, those who haven't done till now. Ask all your friends to be a part of this class as soon as possible. Tell them that Ameer Bhaiya is going to start the class within no time, and we are going to start solving the questions from which chapter? From the chapter of atoms. So jaldi, okay, take everyone to the class, all your friends, and it will be a bit fun for you also to have your friends in the same class, right? Okay. Now, if you have any doubts related to the Unacademy subscription platform or any queries, you can get in touch with the counselor. The number is given right here. Fine. So, ये क्या है? ये कहाँ से आ गया भाई? ठीक है. Open house sessions keeps on happening. You can come and join the classes. Okay. Now, offer is going on, मेरे बच्चा लोग. If you go for 3-month subscription, extra 1 month is given free, and this is valid only for the first 500 subscribers. So try to be one among those 500 subscribers. Fine. ठीक है. And here we are with the very first question. Let me know how many of you are ready for that. Yay, Kanika. Hello, Ria. Mithilesh, good afternoon. Where are your friends? Where is everyone? Is everyone sleeping out there? Good afternoon, Sana, after a very long time. So, just carry all of your friends to the classes, okay? Just pull them out of the bed, okay? Ask them to open their phone and ask them to open the YouTube, and here we are in our channel, right? Okay, so expecting every one of your friends to join as soon as possible. Share the class with all of them, those who are not still aware of the class happening. Hi, ready everyone? Ready for the classes? Ready for solving the questions one by one? बहुत सारे questions है. I'm planning or I'm thinking the session is going to be extending at least for the next 2 hours. I hope you all came with enough energy, right? Yeah, school. Okay, seems like everyone is in school, not sleeping. Okay, so Mithilesh, option B there. Okay, anyway, everyone keep on giving me the answers. Let's see. Let's see. The question is right in front of you. So read the question, try to understand in the best way possible, and try to give me the correct answer. This is your time. Okay, time is all yours. Okay, I can see 2 people already with the correct answers. I'm not telling, sorry, not correct answers. Let me say answers. Correct or not, we will decide by doing it together. Saloni, good afternoon. Mithilesh, B. Kathyaini, B. Then, who else we have? Who else we have? Who else we have? Okay, Ria also going with the option B. Okay, so many of you are going with the option B. Let's see whether the option B is correct or we have some other option as the correct one for this particular question. Here it goes. The ratio of wavelength of the last line of Balmer to the last line of Lyman series. Question here, in general, what we need to find out? We need to find out the ratio of wavelength of Balmer series to wavelength of Lyman series. Okay, this is what we need to find out. So let us write down the formula for wavelength of Balmer series and Lyman series, solve it, and then we can find out the ratio of this. Tell me, what is the formula for wavelength of Lyman series? We all have learned that is equal to R into 1 by 1 square minus 1 by n square. Okay, so R corresponds to Rydberg constant. Let it be a constant because we are only interested in finding out the ratio. And n corresponds to from which orbit the electron is falling to the first. Because if the wavelength wants to fall in Lyman series, the electron has to jump from any higher orbit to the first orbit, isn't it? Yes. Now, here it is being specifically given that last line of Balmer series. So what does the last line of Balmer series means? Now, last line means the electron is falling from where? From infinity. If the electron is falling from infinity to the first orbit, we say that last line of Lyman series. Okay, not Balmer series. It's my bad. So last line of Lyman series. So that's it. Just substitute n equal to infinity here and get the answer. 1 by lambda of Lyman is equal to R into 1 by 1 square is 1. That's it. Similarly, let us write down the formula for Balmer series also. 1 by wavelength of Balmer series is Rydberg constant. 1 by 2 square it is minus 1 by n square. Here also we talk about last line. N का value कितना होता है? N का value infinity. We already have explained the concept. So substituting infinity, array 1 by infinity 0 hai. Don't think that sir, why it is 1 by 1? What happened to this n when we substitute as infinity? 1 by infinity square ho jayega, that is 0. Everyone knows, right? Array give me a smile if you know. ऐसे पता है, ठीक है. Same thing, substituting n equal to infinity here, we will get r by 2 square is 4. 1 by Balmer series, this is second and this is first. Clear? We need lambda b by lambda l. What I'm going to do? Equation 1 divided by equation 2. What will you get? On the left hand side, 1 by lambda l divided by 1 by lambda b. Once again, on the left hand side, 1 by lambda l by 1 by lambda b. That 1 by lambda b will be going up. So it will be lambda b divided by lambda l. Right hand side, r divided by r by 4. That 4 will go up. And here it is. मिल गया? देख ले. Yes, as you all were telling, yes, it is the option B which is the correct answer for this particular question. Nannu munnu pyara question hai. I hope you all got the concepts, right? Let me see, give me some thumbs ups here in this classroom and let me see some smiling faces in the classroom if you all got the concepts. If you all got it, Riya, Sahil, Mithilesh, let me see that smiling faces. E wala smiling faces from every one of you. Where is it? And you all can note it down in the meanwhile when I give these kind of casual talks. Okay. So what you can do is, like, those who want to note down all these notes, you can do it very faster. Yes, clear? Sana, Sahil, everyone? ठीक है? Yes, there goes the smile with my smile, Sahil boy. That's good, Sana. Very good. That's an awesome smile you have out there. Mithilesh, very good. Okay, fine. But whenever I ask you to smile, the smile should be like this, with the teeth. Then it will be so good. What do you all say? Because this smile is so forward. That wala smiley, right? I like this one with the teeth shown. Anyway, good. So moving on. Next one. So do this. It's a very good question. Take it seriously and do it. Let's see. कौन बनेगा करोड़पति? So किसको मिल जाएगा सही उत्तर? Who is going to get the correct answer for this? Yes. Okay. Satyam Rai is giving that one. That is not the smile. That's not the smile. This is the smile, right? Okay, Mithilesh already giving. It is the third option which is correct. Others? Sana is also going for the option C. Everybody wait there. Now this is your time to solve it. After this, I'm going to explain the concepts in detail. So be here when I explain this so that this part will be super clear to you. That energy part. Okay, Sahil is going for option A there. Muskan is going for option 3. Juhi for 3. Satyam says option C. Okay, everybody have expressed their own options. Isn't it? Yes. Let's do it. Everybody. Everyone listen. The diagram shows the energy level for an electron in a certain atom. Okay. Which transition represent the emission of a photon with the maximum energy? First, let us discuss. When will an photon be emitted? When will a photon be emitted? When electron moves from higher orbit to lower orbit, right? In this particular case, right, and photon will be emitted. Tell me, what will be the energy of photon equal to? Energy of photon will be equal to, energy of photon is equal to difference in energy of orbits. When an electron is moving from an orbit of n1 to n2, whatever is the difference in energy of those orbits will be equivalent to the energy of photon. So the one which has the maximum energy of photon will be equal to the one with the maximum difference in energy of the orbit. So from the figure, let us find out which one has the maximum difference in energy of the orbits. ठीक है? Fine. Now look at the first case. Electron should move from a higher orbit to lower orbit for photon to be emitted. But from here, the transition is from lower orbit to higher orbit. Will a photon be emitted? No. This will not happen. In the first case, energy emission will not happen. Photon is not emitted. Because for photon emission, electron should move from a higher orbit to lower. This should be the direction. Okay. Now in the remaining three cases, yes, photon will be emitted. But question is the one with the maximum energy. How will we find the one with the maximum energy? Where there is maximum difference in energy of orbit. So ठीक है, let us give energy to all the orbits. Formula क्या है? What is the formula to find out the energy of each of the orbits of a hydrogen atom? कितना है? That is equal to energy is equal to energy is equal to minus 13.6 z square by n square. Z corresponds to the atom we are talking about, atomic number, and n corresponds to the orbital number. So for ground state n equal to 1, energy कितना हो जाएगा? Minus 13.6 z square by 1 square. Because n takes the value of 1. For the second, minus 13.6 z square by 2 square, that is 4. For the third, minus 13.6 z square divided by 9, and this is minus 13.6 z square divided by 4 square, that is 16. Okay, now z is common for all the transitions. Now let's see which one is going to be having the maximum energy difference during transition. देख ले, if it moves from 2 to 1, how much will be the energy difference? This is 13.6, this is 13.6 divided by 4, almost minus 3.4. So this difference will be coming around, this difference in energy will be coming around 10.2 z square. Keep it inside. Okay, first one. Now let us look for the second one. When it moves from 4 to 3, array, here the difference is very less. देख ले, 13.6 by 16 by 13.6 divided by 9, very small difference in energy will be there. Delta E very small compared to the first case. Even in this case, देख ले, 13.6 by 16 and 13.6 divided by 4. Here also the difference in energy, if you calculate, if you look at, you can see this difference in energy is very nannu munnu compared to this difference in energy when electron make a transition from 2 to 1. Isn't it? So it is in this particular case, the difference in energy is more. Difference in energy of orbits more in that case. If the difference in energy of the orbit is more, right, energy of the photon emitted is more. Because we already know from the Bohr's concept that the energy of the photon emitted is equal to difference in energy of the orbits. So which one is our option? This one, the third one, which corresponds to transition from 2 to 1. Is the concept clear to every one of you? सबको समझ में आ गया? Is it clear? For every one of you, अच्छे से, नन्हे से, मुन्ने से, प्यारे से, right? Every one of you. Yes, Anna. Very good. Yes, Mithilesh. Correct answer it is. Very good. Okay, let that spirit be there throughout the session. समझ आ गया ना साहिल? Yes, Riya. Suhani. Very good. Very good. Awesome. You guys are great. So, let us move forward. Here we have the next question. All questions are simple only. As all questions are very simple for today's session, what I'm going to do is I'm going to explain the concepts related to each question in detail so that the smile will automatically come to your faces. क्योंकि समझ आ गया तो मजा भी आ जाएगा. Isn't that what people say? Yes. Mithilesh, wow, super fast there. going for option C. Ria also going for option C, which says 4860. Then Arshpreet ma'am ki, okay, Karan, option C. Cool. Ria, Sana. Okay, I think everyone here in this classroom already gave me the answer. Everyone is going for the option C there. Okay, let's see what the question is. Listen, everybody, you done your part. Now listen, let's see what are the inner concepts hidden in this question. If the wavelength of the first line of the Balmer series of hydrogen is 6561 Armstrong, okay, the wavelength of the second line of the series should be. Now, I'll explain this. First line, second line, what all these things corresponds to. Have a look here. Okay. This is our nucleus. This is our first orbit, second orbit, third orbit, fourth orbit. Tell me, when can we have the Balmer series? Whenever the electron moves from any higher orbit to the second orbit. The first line of Balmer series is obtained when the electron transition happens from n equal to 3 to n equal to 2. This is first line. First line of any series का मतलब ये है कि the electron moves from the next higher orbit to its base orbit. Because for every series there is a base. For Balmer it is n equal to 2. For Lyman n equal to 1. So similarly there will be a base orbit, right, for which all the series works. ठीक है? So this is the first line of Balmer series. Second line of Balmer series is from the next higher orbit to n equal to 2, which means that is n equal to 4 to n equal to 2 if the electron transition happen. This is what we call it as second line in Balmer series. And the question is to find out the wavelength corresponding to this transition. Clear, Anna? Now what is left? Let us write down the formula for each of the cases for wavelength and get the answer. That's it. Formula. What is the basic formula? 1 by wavelength is equal to R into 1 by 2 square minus 1 by n square. In the first case, lambda ka value, how much is it? 6561 is equal to Rydberg constant. 1 by 2 square is 4 minus 1 by n square. What is the value of n in the first line? 3. So 3 square, 9. So how much is this going to be? 9 minus 4, 4, that is 5R by 36 is equal to 1 by 6561. First one. Any doubt in that? No, I suppose. We just have substituted the values according to the information given in the question. Okay, let us go for the second one. Question is, when it moves from 4 to 2, what is the wavelength? So we don't know the wavelength value. I'm putting it as lambda dash is equal to R into, formula is 1 by 2 square, that is 4, minus 1 by n square. From where it is moving? From 4. 1 by 4 square is 16. So simplifying, R into 16 minus 4 is 12 by 4 into 16. Right? If we write the same here, 1 by lambda dash will be equal to 4 into 12, how much? 3 times. So 3R divided by 16. Let's call this as equation 2. We want to find lambda dash. क्या कर सकता है? क्या कर सकता है? अरे equation 1 divided by equation 2 on the left hand side. 1 by 6561 by 1 by lambda dash. So lambda dash goes up, divided by 6561. Okay, 1 by 2 is what we are doing. On the right hand side, 5R by 36. 5R divided by 36. The whole divided by this will be 3R divided by 16. R and R will cancel. 5 by 36 into 3 into 16 is equal to lambda dash. This 6561, you can write it here. Okay, so lambda dash, which is the new wavelength, is 6561 by 36 into 3. Math, though, you guys are the tigers there. I know that you all are super good in that. If you do the math here, you will get it as 4860. Any confusions here? Any nannu munnu confusions? Karan Mithilesh, yes, it's correct. Very good. Awesome. So it's option C which is correct. Sab badhiya? Array simple dimple. Okay, good to know that. Good to know that. No doubts. Okay, so I can just see so many thumbs ups and smiles there. So I hope the concept is super clear, isn't it? Yes? Okay. So moving on to the next one. Super clear, right? Okay. Bharat, Sana, everyone, the concept is super clear. So next question is right here in front of you. Have you all started giving the answers? Mithilesh is going for option B there. Clear. Muskan Art Craft Mehendi. Okay. Karen also with the option A there. (13.6/9), the answer by Ria. Then who else we have? Who else we have? Shika with B, Sana with B. Hello, Subhlal, right? 13.6/9. Okay, fine. Everyone or many of you, I think, is going for option B. Some have opted for option A also. Let's see, देख लेगा, है ना? ठीक है. The energy required to knock out the electron in the third orbit of a hydrogen atom is equal to. First, let us find out what is the energy associated with an electron in the third orbit of hydrogen atom. Formula kya hai? What is the formula? Energy of electron in the nth orbit is minus 13.6 z square by n square. Z corresponds to the atom or hydrogen like atom we are talking about. N corresponds to its orbit. Which atom here we have? Hydrogen. So Z ka value kitna? 1 atomic number of hydrogen. Now which orbit we are talking about? Third orbit. So substituting n equal to 3. So substituting all these values, energy of the nth orbit or third orbit is minus 13.6, 1 square by 3 square, that is 9. Which means energy of the third orbit of the hydrogen atom has an energy of minus 13.6/9. Tell me, what does this negative sign corresponds to? Ye negative hai na? What does it corresponds to? Okay, it simply means that this electron is in a bounded system. Bounded system का मतलब क्या है? इसका मतलब ये कि, or it means that the electron is bound to nucleus. It is attracted to nucleus and it has to move in that fixed path decided by the nucleus, because an electron is always bounded to the nucleus. That's what negative sign means. It can be explained also in another way. First, I'll write the first part. First meaning is it is bound to nucleus. It is attracted to nucleus. The second meaning of this negative sign is that, right, we know that energy is always scalar. So the least energy any body can have is 0. Okay. So negative sign means, right, the body is losing energy even from 0 energy. Okay. Why the body has to lose energy from 0 joules? Because as long as the energy is being lost from the body, as more and more energy I am giving out, what happens? More the stability, because the body will have more stability with lesser energy. So electrons are revolving around the nucleus. It needs to be stable in that particular orbit. So it is for attaining the stability, the electron in the third orbit is losing this much of energy so that it can stay bound to the nucleus. So second part, we can say that lost energy, that negative sign corresponds to energy lost by the electron to stay bound to the nucleus. So if you want to take out an electron from that fixed orbit, what we need to do? We have to provide this same amount of energy. How much is the same amount of energy? 13.6 by 9. That much of energy has to be supplied to the electron so that you can take that electron from the orbit. How and why is that? Because the electron has lost this much of energy for retaining stability. Now if we give this much of energy, the electron will be free again. It can move away from that orbit and it can start moving by itself. So how much energy we have to give? 13.6 by 9 with a positive sign. Positive means we are giving that much of energy to the electrons to make it free. Okay, very good, very good. Yeah, Mithilesh, awesome. Electron attracted by the nucleus. Yes, yes, yes. Sahil, aa gaya hai na? Tiger, A. I think the option is B here, not A. Cool, correct answer. Very good, awesome. You guys are awesome. Okay. So, yes, moving on, moving on, moving on. Copy किया ना सबने बच्चा लोग? Have you all noted this down? This है ना, this is very important. What all notes I give you, what all important concepts I give you, don't forget to note it down. It has a very important meaning all over here. Okay, yes, correct, correct, correct. Yes, Badhiya, Mithilesh, Riya, Sana. Next question is here. So start reading the question and start solving the question. Once you start solving, you'll understand. Ye to nannu minuta. Actually, just need to remember that formula to find the radius of the nth orbit of any hydrogen-like atom. You might have realized this particular chapter you can score easily once you remember all the formulas from the chapter. Okay, nothing more conceptual is there. Does anyone have the answers here? Okay, Mithilesh we have, Riya we have. Then who else? Who else? Who else? Who else? Sana we have. Very good with option C. All are going for option C. Is it correct? Correct hai kya? Let's see. Let's see whether the option C is correct or not. Here we go. Using the known values for hydrogen atom, okay, calculate the radius of the third orbit of lithium 2 plus atom or ion. Formula kya hai? What is the formula to find out the radius of nth orbit of any hydrogen-like atom? Formula is, yes, n square by z into 0.529 with the unit of Armstrong. This is a constant, 0.529. So many times you will find this 0.529 written as R0 and called with a name of Bohr radius. Okay, this is with the value of 0.529, we usually call it as Bohr radius. Why the name Bohr radius? Because they claim for the first orbit of hydrogen atom, what will be the radius? N equal to 1, Z equal to 1. First orbit of hydrogen. 1 by 1 into 0.529, which is 0.529. Matlab ye ki 0.529 is the radius of first orbit of hydrogen atom. Okay, so that's why the name Bohr radius. Okay. Anyway, that's not our concern here. Obviously, we need to know that. But for this question, what is given? Radius of third orbit of lithium. Third orbit ka matlab n equal to 3. 3 square. Why? Z atomic number of lithium kitna hai? How much is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How much is it? It's 3, right? Lithium. 3 square by 3 is 3 into 0.529 is 1.587 Armstrong. Option C it is going to be. Like I said, if you know this simple formula, the answer is in your hand. Isn't it? Network issue हो रहा है? अच्छी बात नहीं है. Call your service provider. Jashanpreet Kaur. Pre-board है आपका? अरे don't get scared, okay? Go easy on you. Have a smile on your faces. Just attend your exam with that smiling face. Everything is going to be okay. No worries at all. Okay? Yes? Fine. All good. Okay, there you go. So moving on to the next. Here it is. Most of the questions are conceptual questions. So I am expecting every one of you to give me the correct answers. Okay? Keep it going. Keep it going. Okay, now look into the answers given by you. Sahil Sharma is going for option C there. Mithilesh is going for C. Then, jaldi bacha log, show me that vibe you all have. Okay, how much excitement, that energy you all have. I know it's 2 o'clock or 2:40, whatever it is, the time is, right? So it should be like when you come to Bhaya's class, you should be having that energy, right? Or at least I should be proud of that particular fact. Sahil C. Minu is like B, maybe. Sir, I'm not so sure. Okay? So if you want to take, you can take it. It's fine. Ria is going for option C. Harshida with C. Sahil with C. Right? All good? Okay, great. Here we go. Using the known values for a hydrogen atom, calculate angular momentum of electron in the third orbit of helium. Formula क्या है? Angular momentum of nth orbit of any hydrogen or hydrogen-like atom is equal to n times h by 2 pi. Isn't it? Where n corresponds to what? N corresponds to the orbital number. Array, we are talking about the third orbit. So directly substitute. N का value होता है 3 times h by 2 pi. Simple, dimple. मिल जाएगा आंसर ऐसे ही, right? And yes, the answer is 3 times h by 2 pi. Option C is our correct answer. Any doubt? I don't find anyone will find this question hard. Because ये तो नन्नू मुन्नू प्यारा वाला question है, right? Yes, yes it is. Who is spreading the false information here? Use the code. There is no Mendy happening, so please don't spam here in this class. Who that person is? कौन है? कौन है ये बंदा? Vilas, अरे Vilas भैया, kindly don't spam here and please don't spread the false information in this class. We are not doing any Menti to all my bachalos who is listening to me. Okay. So, shall we proceed to the next? ये तो simple dimple नन्नू मुन्नू question था. Next one. ये थोड़ा अच्छा वाला question है, right? This is a bit good question compared to the previous one. Not like a bit good question or bad question, right? A bit tough question compared to the other one. So try doing this. And this is a colorful question, of course, obviously. Okay, by seeing only white and black for all the previous question, you must be like, sure. Again, this white and black color. Here I have included which all? Yellow is there, black is there, white is there. Then this borderline, which one is it? Some kind of blue, random blue. And original blue is there on the sides. So it's a colorful slide we have. Mithilesh B, Ria B, Shana B, Sahel B. Okay. All are going for the option B here, which says V by 2. Okay. Let's see. The orbital speed of electron in the ground state of hydrogen is V. Matlab, for n equal to 1 and z equal to 1, right, the orbital speed is equal to V. Because ground state matlab n equal to 1. Hydrogen atom means atomic number z equal to 1, the speed is V. In that case, question is, what will be the orbital speed when it is excited to the energy state of minus 3.4? Directly they are not giving us the value of orbital number. Instead, what information is given? The simple information given here is, right, when it is excited to that orbit, the energy is minus 3.4. Okay, let us find out the orbital number. For that, let us write down the general formula. Energy of an electron in the nth orbit is minus 13.6 z square by n square. How much is the energy of the nth orbit given? Minus 3.4 is equal to minus 13.6 z atomic number of hydrogen atom, it's 1 by n orbital number pata nahi, and that's what we need to find out here. Rearranging, what will we get? N square is 13 by 6 by 3.4, that's 4. So n ka value 2n. Sir, n square equal to 4, n equal to plus or minus 2. Minus 2, does it have any relevance here? No, because n is actually corresponding to the orbital number. Minus 2 orbital number, it doesn't even exist. So we go for the plus 2 number. Okay. Okay, fine. N equal to 2 mil gaya. Let us find out what? The speed. Speed ka formula kya hai? Speed is equal to z by n into v naught. V naught corresponds to the velocity of hydrogen atom in the ground state, which is given here as v. Substitute kar le. It is a hydrogen atom, z ka value 1 hai. N orbital number, it's 2 into v naught. Okay, here v naught is given as v. So the present value of velocity, let's call as v dash, that will be equal to v by 2. Kyunki v naught ka value according to the question is v. So I have substituted v naught is equal to v there. So v by 2 will be the correct answer. Okay. So this was a chotu motu nannu. Let's call it as application level question. Nothing more than that. Okay. So kitna earn kar lete ho? Are you asking this question so that if I earn less, you'll be sending some money to my account? Is it so, Anti? Mithilesh, correct answer, right? Sana, Nanu Munu. Okay, yes, it is Nanu Munu. Nanu Munu, nahi, Nanu Munu. Okay. Sahil, yes. Riya, yes. Any doubts, anyone? On any of the steps we have chosen to get the answers? Your time. Anyone? With the doubts? Anyone here in this class? You can ask me. Okay. So all I can see is smiles. No doubts, right? Okay. Fine. Kanika, I have my pre-board today. When is it, Gandhi? Update us. When is your exam going to be? So everybody says, sir, we don't have any doubts here. You just do lunch. Okay, Mithilesh. Go and enjoy having a very good, awesome meal out there. For me to have lunch, this class has to end. Koi baat nahi, I can wait. Question to given, so do it wisely. "15th, look at the commitment Mithilesh is having, right? Even he has planned to go for the lunch. He is like, let me give the answer to this question at least, then I'll go for the lunch. Very good. Riya, 5 to 2. Okay. Then Sahil is going for B. Riya is going for a D out there. D is okay, 5 to 2. Okay, fine. Let's see. Sahil, Kanika, Meenu, everyone is going for option D there. Let's see. Which of the following transition will have highest emission wavelength? Let's see how the transition is dependent upon wavelength. Then we can choose the answer. Okay. We already have seen whenever electron makes a transition, a photon is being released. From where to where it has to make the transition? From a higher orbit to lower orbit. We already have discussed all these things. From higher orbit to lower orbit, if the electron makes a transition, a photon is emitted where the energy of photon is equal to change in energy of orbits. So question is, for the photon emitted, when can it have the maximum wavelength or highest wavelength? अरे we know energy of photon का formula है h nu or h c by lambda. H times frequency, frequency is equal to c by lambda. Substituting the same, h c by lambda is a change in energy of orbits. Okay. Now tell me, when the wavelength has to be larger, what should be the change in energy of orbits should be? It should be lesser because they are inversely proportional. So to find out that transition with a larger wavelength, we should be going for that one with lesser change in orbits. Okay, let's see. Here we have transition from 1 to 2. Will a photon be emitted? No, because for photon to get emitted, basic need is it has to move from higher to lower. So this will not happen. So similarly, we can say that 2 to 5 moving from lower to higher, again photon is not emitted because for photon it should move from higher to lower. This also doesn't happen. Now we have two different cases, moving from 2 to 1 and moving from 5 to 2. In both the cases, electrons are moving from a higher orbit to lower orbit. Okay, so in both these cases photons are emitted. Now we will see among these two conditions which one is having lesser difference in energy of orbits. Okay, so let's find out. देख ले, when n equal to 1, when the electron is in the first orbit, how much is the energy? Minus 13.6 by 1 square, isn't it? The formula to find energy of nth orbit of hydrogen is minus 13.6 by n square. So n first orbit, it's 1 square. Energy of kitna second orbit is minus 13.6 divided by 2 square, that is 4, so that will be minus 3.4. 13.6 minus 3.4, difference in energy, how much? How much is the difference in energy here? This difference in energy will be equal to 3.2. So when the electron makes a transition from 2 to 1, 3.2 nahi, difference is 10.6. My bad. Okay, so when it makes a transition from 2 to 1, the difference in energy is equal to 10.6. Clear? Now let us go for the last option, 5 to 2. Energy of the second orbit we already have. How much? Minus 13.6 by 4, that is minus 3.2 almost. Okay, what about n equal to 5? Energy of fifth orbit is minus 13.6 by 5 square. Arey, ye value hai na, it will be very less, minus 13.6 by 25. So the difference between these two, minus 3.2 and minus 13.6 by 5 square, small value will it be compared to this 10.6. Okay, so here delta E will be smaller and we want that transition with lesser difference in energy, isn't it? Yes or no? That is something which we already have found out or we already have discussed, right? Yes. So that itself is our correct answer. To have a larger wavelength, we should choose those transition with a lesser difference in energy, and that comes for the option D here. Is it clear? All the concepts to you in much amazing way without any doubts here. You can note down everything. Is it clear? Is it clear? ये pure English वाला सारे. So is there a category of teachers? Pure English वाला, English वाला, right, and pure Hindi वाला. मेरा हमेशा सही था. बिल्कुल बढ़िया है फिर तो. हाँ जी सर. So I come in that category of pura English. But I'm talking Hindi in between. ऐसे छोटू मोटू नन्नू मुन्नू. So won't I be considered for the second option where I'll be talking Hindi and English? Am I not considered there? Okay. So I think I need to learn better Hindi for that consideration. But anyway, I like to and I love to explain the concepts here in English itself. Physics will always be explained in English. That's what I like. Okay. Those who love that can join my classes, right? That'll be awesome. सर हेलो आप हेलो नहीं बोल रहे ठीक है हेलो खुशी हेलो बोल दिया अभी सो डन okay so let's move to the next one here we have from here onwards you can find many smaller questions matlab direct questions or theoretical questions how many of you do love this theoretical question solving questions will be directly from the theory one word question just like that ये सब हमको नहीं चाहिए भाई does anyone have the answers already here okay very good Sana with the option C okay then answers only one answer I have got मेंटी भी लेता था लेकिन अभी नहीं okay C D okay people are having difference of options why was Rutherford's atomic model unstable because Rutherford considered the model of the atom and compared the model of atom to the solar system where we have sun and the planets revolving around so accordingly Rutherford said that instead of sun here we have the nucleus and instead of planets revolving here we have the electrons revolving but there was a major difference with the planetary model and the atomic model that was charges planets was neutral and here the electrons are charged particle and he forgot one thing that the charged particles when it moves in circular path or when it accelerate it will be radiating electromagnetic energy he forgot that particular concept and that was the biggest failure for Rutherford's atomic model because electrons are revolving around the nucleus as zoom 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 right when any particles moves in circular path it will be accelerating centripetal acceleration when charged particle accelerate it will be emitting out electromagnetic radiation or it will be emitting radiation or energy so if the electrons keep on radiating energy will it be stable in an orbit no it will be radiating or emitting energy and finally it will fall into the nucleus so that was the problem with the Rutherford's the Rutherford's atomic model orbiting electrons radiating energy and that made the Rutherford's atomic model to be a failure okay fine this is a good question and that concept will be reviewed D is correct okay yes okay मेरा गलत हो गया okay कोई बात नहीं mistakes happens keep on happening right you just need to correct yourself that's it इतना simple and इतना नन्नू मुन्नू वाला question don't miss it try giving me the answer within no time 0 seconds पे everyone okay here we have Ria with the option B okay Indushri with visible Elma B Ria B Arey, you don't need even seconds to give me the answer for this question ऐसा वाला question direct question is it Yes, yes, yes. D is correct answer. Awesome. Good. So it's like a Suhani, Indusri, everyone is going for the option B there. Yes. Balmer series lies in which spectrum? It lies in visible spectrum. That's the answer. Got it, right? Okay, and that is a simple definition of Balmer series itself, I suppose. Okay, moving on. Next. Uh-oh. When I see super simple question, this is my usual tone which comes out of my mouth. Uh-oh. Because when I was in my 11th and 12th, I wished there were some easy questions either given by the teachers or in any of the exams. Just like you all do. Every student does that. So yes. So they I'm giving you, I'm that person. I'm that angel, let's quote it. Right? Who brings you with amazing simple questions. Or genie. How many of you know Aladdin and the genie? The first discovered due to visible. Wah Sahil Wah. Extra informations. Very good. This one. Arey, the question itself is wrong, right? According to the classical theory, right now I have observed this. Okay. According to the classical theory, the circular path of the electron is circular. Arey, I hope you understood, right? Arey, there has to be a blank space here. The dash or the path of the electron is. That's how the question is, or it should be, right? According to the classical theory, the path of the electron is, the answer has to be circular. And seems like the content person, when he made it, he added already the answer. How many ways to get questions like this? Okay, where already the answers are printed. Let's say you are writing your JEE or NEET or whichever exams you are preparing for. Okay, you're writing the exam, and suddenly there comes a question where already the answer is in between the questions. How happy you would be out of 1 to 10? Tell me how much happy you would be out of 1 to 10 if you get this kind of a chance. कितना हो जाएगा? 10 out of 10, Suhani. That's what I want to hear, है ना? They're like, students are like, हाँ, but sir, it's 10 out of 10 wala question. If there comes a kind of question like I have mentioned, it will be awesome, right? I would also love that. Okay. Anyway, moving to the next. Ria, 9 out of 10. What happened to 1? I don't have any number to express it. Elma Khan. Minu C, Sahel C. Everyone is going for option C. Okay. Keep it going. Keep it going. Sahil C बोल रहा है. Sahil Sharma, another Shamil. Sahil. 2 Sahils here in this class. Riya C, Suhani C, Shruti C, Khushi C. Everyone, Riya C. But chalo, if you are liking the class, don't forget to press that like button, okay? That's how you simply express, sir, what you're doing is awesome. Okay, we are liking it. Keep on giving us such kind of classes. Ria, Sana, Elma, Pinky. Pinky is only saying hi. Others all have given the option C there. Let's see. The electrons of Rutherford model would be expected to lose energy because it radiates electromagnetic wave. Just now, because electrons, when it is revolving around in circular path, it will be associated with centripetal acceleration. So electron, a charged particle, accelerate. When charged particles accelerate, what will be produced? It produces electromagnetic waves or radiation. So here it is. So it loses energy because of the production of electromagnetic waves, or it radiates EM waves. Fine. Nannu Munnu, that's what we call, right? Okay. To the next. Uh-oh. You know why I made that sound, right? Uh-oh. Okay. So we should classify the sahils as normal sahil and regular wala sahil. Okay. Done. Classified. Who discovered the first spectral series? First spectral series. Question is not, right, the spectral series where the electrons jumps to n equal to 1. Electron jumping to n equal to 1, that is Lyman series. The question is, which spectral series was discovered first? Is it Lyman, Balmer, Paschen, or Fun series? Answer. Very good, very good. One person have given me the correct answer with the explanation. I'm so happy for that. Ria also, yes, option B. Yes, it is Balmer. Okay, so Balmer actually started the discovery of all the spectral series, and it was very simple for him to discover this spectral series, which was named as Balmer series itself. Do you know why? Because this spectral series or the spectral lines falls under visible light. Matlab, during the electronic transition, the photons emitted or the energy emitted comes under visible light. So we can actually see those lights coming out during the electronic transition. So if we can see something with our naked eyes, can't we discover it within no time? Yes, and that's what exactly he did, Balmer. For Lyman and Balmer, Lyman, Paschen and Fun series, all those things, right? They have to actually see through other methods, because Lyman series is in UV, okay, and Paschen, bracket, Fun, all those comes under infrared, which is not visible to our naked eyes. Hai. So it was Balmer who discovered the first spectral series. Okay. B, understood. Understood what was a mistake. So try to avoid all the mistakes that you make for all these nannu munnu questions. Okay? I'll write, try avoiding what? Mistakes for at least what? For nannu munnu questions. For at least these kind of nannu munnu questions, try to avoid the mistakes. So think twice. Try to understand the concept of the question at least, okay, before you just jump for the answers. Next. The second postulate of Bohr. That's what the question is all about. Nannu Munnu, she is like laughing. Sure. So which one is this? Which of the following did Bohr use to explain his theory? Which one? So the new era thinkers is going for option A, Ilma is for B, Barbie doll A, then who else we have? Unique A, Ria A, Sahil A. Very good afternoon, ma'am. Okay, fine. Okay, Sahil, Suhani, Ria. Then who else we have? Minu, Barbie doll. Everyone is going for option A here. Let's see. Which of the following did Bohr use to explain his theory? He told that in his second postulate, electrons will only be revolving in those orbits where the angular momentum of the orbit is an integral multiple of h by 2 pi. So by equation you can write L should be an integral multiple of n times h by 2 pi it should be. If this condition is being satisfied, those orbits exist, and it is in those orbits only the electrons will be revolving around the nucleus. And this is what the Bohr's entire theory is dependent upon. Clear? So it is the quantization of what? Angular momentum. Quantization matlab the angular momentum will only be having some specific values. And he mentioned what is the condition for that specific values of angular momentum is going to be. Yes, done? Yes, quantization of angular momentum. Yes, Suhani. Sahil, yes. Ria, how many questions are left? Almost 14. Okay, let's say almost 5. Sorry, not 5 questions. 13 questions are left. Let's say. Okay, so to the next one. Another good conceptual question. Start reading, and your time to give the answers which you know. After that, I'll give you my explanation. It's a good question, I'll say that. I'll say this is a good question. Okay, Sahil is B, Unique Girl is B, Princess Huda is B, okay, Sana is going for B. Done, Sahil. Okay, then you can give me the answer there. Everyone is going for option B there. Let's see. Okay. In Bohr model of hydrogen, PE represent potential and TE represent total in going to a higher level. In going to a higher level means if electron is moving from a lower orbit to a higher orbit, what happens to the potential and total energy? And we already have the formula for total energy of the electrons in an orbit. That is minus 13.6 divided by n square. Now, if the electron moves to a higher orbit, n value will increase. So, if n value increase, which is in the denominator, 13.6 by n square, that numerical value or the magnitude value decreases. Okay, when negative value of magnitude decreases, I'll say initially let's say it is minus 13.6. After some time it became minus 3.4, right? Because as n value increases, this numerical value is decreasing because n is in the denominator. Tell me what is happening to the value actually. If minus 13.6 becomes minus 3.4, is the energy increasing or decreasing? Array increasing. Total energy increases there. How can we say that? Because minus 3.4 is greater than minus 13.6. I think I don't need to explain you that. Right? So, as it moves to a higher level, total energy is increasing. TE increase हो रहा है. Okay, what about potential energy? Let's see, same concept it is. Here we have the nucleus, right? With the nuclear value of Ze. Now, electron is moving away with electronic charges minus E. Electronic charges minus E. Tell me what is the formula for potential energy? Array, potential energy formula existing between two charged particles. Electrostatics chapter. Formula is 1 by 4 pi epsilon 0, we'll write it as such, 1 by 4 pi epsilon 0, which is a constant, Q1 into Q2, that is Ze into E, Ze into E minus, because electron is having a negative charge, the whole divided by square of the distance. Okay, again देखले, as the electron moves away, radius value increases, which means the magnitude value decreases, right? Magnitude will decrease, but it is associated with a negative sign. Okay, when the magnitude of a negative value decreases, the actual value is actually increasing. Same concept, just like I have explained above. Okay, clear? which means even the potential energy is increasing, both is increasing, so we can go for the option D here. समझ में आ गया? Total energy बढ़ रहा है and potential energy also increasing. Both are increasing here for this question. Clear? Clear, Sahil? All good? Good afternoon, good afternoon. कोई बात नहीं, unique girl. Okay. So I hope the concepts are clear for this particular question and you are enjoying it, isn't it? Yes, 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 Sahil. Yes, unique girl. Okay, moving to the next one. Next. J.J. Thompson's theory, atomic model. Do you remember? Pehla wala, that plum pudding model. Okay, so there we have positive charge uniformly distributed, right? And electrons are embedded in the volume of the entire atom. That's what J.J. Thompson's model is about. I hope you do remember. Okay, just like a watermelon, red color of the watermelon corresponds to the nucleus, black seed corresponds to the electron. That's what he said. वो था उसका model. Unique is going for D. Then Khushi is for D. Sana is for D. D, 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 D. Everyone is going for D, 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 D options, right? Okay, cool. Everyone says all of the above situations. Let's see whether it is correct or not. Everyone listen. बच्चा लोग इधर. Which of the following statement is correct in case of Thomson's atomic model? Okay. It explains the phenomenon of thermionic emission, photoelectric emission and ionization. All these concepts are being explained. Yes, it is true. It could not explain the line spectra. Okay, I hope you remember that Balmer series, Lyman series. That couldn't be explained by the Thomson's atomic model. That is also true. It could not explain the scattering of alpha particles, right? I think we have seen Rutherford's atomic model or the Rutherford's alpha ray scattering experiment. None of the observations of the alpha ray scattering experiment couldn't be explained with the Thomson's atomic model. That's why Rutherford proposed a new model which is called as Rutherford's atomic model. Anyway, it could not explain the scattering of alpha particle. Matlab, all the three are related to Thomson's atomic model. So we can go for the option all of the above. Just like my bacha logs have said. Okay, so I'll give you the next question here. Everyone, go for it. Jaldi se. Next question is right in front of you. Which one is it? Yes, this one. Okay. So tell me bacha log, is it done? Where is the answers? Where are the answers? Where are the answers? What do you all say? Answers kहाँ है? Answers कहाँ है? Okay, yeah, hi, hello. So Sana is going for option B, Sahil is going for option C. Okay, let's see, let's see. Which one? Okay. Which one did Rutherford consider to be supported by the results of experiment in which alpha particles were scattered by gold foil? Okay, let's see. The nucleus of an atom is held together by forces which are much stronger than electrical or gravitational forces. That is the first part. The force of repulsion between an atomic nucleus and an alpha particle varies with distance according to inverse square law. Read this question once again. The force of repulsion between an atomic nucleus and an alpha particle varies with the distance according to the inverse square law. Is this what he discovered? Yes, this is what he discovered, because he found out that there are some of the helium particles which undergoes deviation. And why this deviation is happening? Dekh, here we have the gold nucleus with the positive charge. Okay, here we have the alpha particle which is helium 2 plus. When helium 2 plus is moving, as it is getting more and more closer to the gold positively charged nucleus, positive and positive will start interacting, and this gold will be pushing away this helium nucleus, because there happens a force of repulsion. Okay, and this force of repulsion will be obviously according to the Coulomb's law, that is 1 by 4 pi epsilon 0, charge of one of the particle, charge of the other, to 1 by r square. So the force existing is inversely proportional to the inverse square, isn't it? Yes, inverse square of the distance existing between the charges. Yes, this is correct, and this is what he found out. Is it clear? So our correct option is option 2. Very simple, nannu munnu wala concept. Okay, clear. Awesome. Very good, very good. Fine. So I think this concept is clear to you. We can move to the next one then. है ना? देख ले. अगला वाला question. Next question. Very clear, unique girl. Crystal clear. Wow, wow, awesome, Elma. ठीक है. Then everything is clear. Go for the answer to the next one. This particular question. जल्दी से. जल्दी जल्दी जल्दी. Sahil, Shukman, Elma is going for B, Shukman is for A, Unique is for A, Suhani for B. Okay, so different options we have. Then anyone else want to give me the answer? Jaldi. Sahil is for A. Unique is like, sir, option A को lock कर ले, इतना सारा confidence, right? Let's see, does the confidence help you all the time or not? According to the Rutherford's atomic model, we know that electrons are revolving around the nucleus. Revolving around the nucleus means it is moving. If it is moving means not stationary. Stationary means it is stationary, not moving. Actually, the electrons are moving, which means the atoms are not stationary. So which option we can go with? We can go with the option of not stationary. Which option? Not stationary. Clear? अरे क्लियर है क्या? बोल दे. हाँ सर, हाँ बिल्कुल. So according to the Rutherford's atomic model, the electrons inside the atoms are not stationary. And there you go. Any doubts if you have, you can ask me, or else we can move to the next one. Yes, Sana, it's option B. Ria, it's kindly check, it's not option A. Right. Aha, Elma, very good. Answer correct hai to. I know that you guys are super good and super intelligent, right? Okay, so yes, moving to the next one. अगला question पे जाएगा हम, and here we have. The Rutherford's alpha particle experiment shows most of the alpha particle passes through almost unscattered, while some of the particles are scattered through large angles. What information does it gives you? What information does it give you? Jaldi say. Answers from the alpha ray Rutherfords. I have actually thought that if I was a person, right, who is doing this Rutherford's experiment, right, even if the helium particles are a bit scattered here and there, we won't mind, you know? The number of particles scattered is very small compared to the number of particles undeviated. So we won't even think in this particular way. So we must all salute all these amazing scientists, right, who actually thought in this way and made all the laws and actually put forward a structure of atom for us, right? You just think that helium is moving somehow. Helium ऐसे जा रहा है, ठीक है? Some of the helium are deviated, remaining is going straight only. Will we think that okay, ठीक है? It is because most of them are moving because the atom is mostly vacant. Some of the particles are deviating because of the positive charge getting concentrated to a very small region, and very few among them is rebounding back because the mass of the entire atom is also localized to a very small region. Will we think in all this way? Never, I don't think so. मैं तो बिल्कुल नहीं करेगा. Right? So yes. So all these deviation of the alpha particle suggests, okay, unscattered matlab atom is hollow. Okay, some are scattered a bit matlab uska ek hi nucleus is positively charged and it is concentrated to a very small region, and some of them, very few of them is rebounding back because the helium nucleus, okay, and the gold nucleus are colliding. Very few ka matlab ye ki that mass of the gold is concentrated to very small region. That's what all these observations of Rutherford's alpha ray scattering experiment suggest us. Clear? Is it clear? Everyone? बहुत बजाहू क्वेश्चन था. बजाहू क्वेश्चन, बड़ा क्वेश्चन आई सपोज. ठीक है, वो क्वेश्चन भी हो गया. अगला, इन the ground state in A, electrons are in stable equilibrium, while in B, electrons always experiences a net force. So here A and B refers to. Okay, in which electronic model or in which atomic model electrons are in a stable equilibrium, and in which one it is experiencing a net force, according to which electronic or into which atomic configuration or to which atomic model. So I used to think same in Newton's case, sir. I would have simply eaten the apple and go home. वो भी सही है. That's also correct, right? Okay, Khushi, Dadu C. NCERT question it is. Okay, good. Elma B, Sahel B, Unique C. Okay, B B B B B B B B. Elma Khan is going for. Right. Let's see. Now we know that it is in Thomson's model, right? The electrons are being embedded in that entire volume of the atom, which means in that particular case, the net force experience is zero by each of those electrons because it is not moving. Okay, so in the Thomson's model, right, the electrons are being embedded in the entire volume and net force is zero because it is stationary there according to Thomson's model. So stable equilibrium in which case? In Thomson's model. Uh, in Thomson's model. Okay, and net forces experience in which model? Rutherford model. Because in Rutherford model, electrons are constantly revolving around. So if an electron has to move in a circular path, it should be given with a centripetal force. Matlab, those electrons are experiencing a centripetal force in Rutherford's model. So yes, B suggests which atomic model? Rutherford's atomic model. So option C is the correct one. Thomson's and Rutherford's model. Yes, that's it. Is it clear? Everyone, is it clear? C, C, C. Yeah, awesome. It's option C. Okay, moving to the next one. Good. Next question is right in front of you. So try solving this. Sir, कितने questions are remaining here? 7 more questions. Last 7 more questions. Okay, we can complete that 7 question in 15 minutes or something, because most of them are theoretical questions only. So by 3:45 class will be over. Crystal, crystal, super awesome clear. Answer? Uni girl is going for B. ये क्वेश्चन समझ नहीं आया किसी को भी? Sahil is going for option C. देख ले everyone. According to the Bohr theory of hydrogen atom, speed of electron, its energy and radius, right, how they are dependent on the orbital number n. Very simple. Write down the formula for each and see how they are related to the orbital number. Starting with the speed. The speed V of any electron in any of the orbit is given by the formula of Z by n into V naught. V naught is the constant, Z is the atomic number, and n is the orbital number. Here you can see speed is inversely proportional to orbital number. Second case is for energy, है ना? Isn't second case for energy? Yes. Energy of an electron in the nth orbit is minus 13.6 Z square by n square, which means energy is inversely proportional to n square. Okay, yes. What about the third one, radius? Radius is n square by z into r naught. Matlab radius is directly proportional to n square. So in order, right, which corresponds to? It is the option D, which corresponds to the relationship of speed, energy and radius to the orbital number. You can see, you can verify it by yourself. Take 10 seconds and copy it down also. This is a main, all these three are very important formulas. Most of the questions will be revolving around these three formulas only. So make sure that you by heart it. ठीक है? Okay, bye bye Riya. Yes, Sahel. So copy किया सबने? Everyone. So our correct answer is option D here. Okay, write down all these formulas. Done, done, done. Okay, अगला question पे जा रहे हैं. Next question is right in front of us. Everyone, just jump for it. Just go for it. Every one of you. जल्दी से, फटाफट से. Answer? In terms of Bohr radius R naught, the radius of the second Bohr orbit of a hydrogen atom is. We already have the formula to find out the radius, right? You just have to substitute the values according to the question and get it done. How many of you got it? Let me see. किस किस लोगों को मिल गया ये? किस किस लोगों को मिल गया? Sana A, Sahil is B4, Khushi A, regular Sahil is for C, Unique Girl is D, Sana is going for A again. So ठीक है, let's see. What was the formula which I told you to find out the radius of nth orbit of a hydrogen-like atom? That is equal to n square by z into r naught. So here, radius of the second Bohr, the value of n is 2 square into r naught by of hydrogen atom ka atomic number z corresponds to atomic number 1. So 2 square is 4r. So radius r is equal to 4r naught. Not a big question, है ना? Actually, we can say this is a Nannu Munnu question. Many of you have given the answers also. Very good. I'm so happy for you all. Sana A, Sumayya A. Good. Cool. All good? To the next one. Okay. You can take 5 seconds to copy this down. 5 seconds. Jum 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 jum. 4 हो गया. Jum 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 jum. 3 हो गया. Jum 2 jum 1. And time is up. So it's 4r naught. Our option is A here. ठीक है? अगला question. When hydrogen atom is in its first excited level, its radius is. And the answer is already 4 times, right? When hydrogen atom is in its first excited state, which is the first excited state? Usually for an hydrogen atom, electron is in n equal to 1. Okay. When it is excited to the second orbit, we will say the first excited. Okay, this is the first excited position of an electron in hydrogen atom. Question is, what is its radius? Formula we already know, n square by z into r naught. N we are talking about is 2. So 2 square, it's hydrogen, so 1 into r naught. So it is 4 r naught, 4 times the ground radius. Because r naught is the radius of the electron in the ground state. So it's 4 times, right? अरे ये question actually was a previous question itself. So उसमें कुछ नहीं है. Let's step to the next one then. This one. Next question is right in front of you. Yes, do it. Every one of you. This one is option A. Is that what you're telling? For this one, I think just now the question was being displayed in your screen. This one? Nanu Munnu. Actually, we can say it's Nanu Munnu, right? Khushi C, Unigirl A, Sahil V, Shweta C, Khushi C. Okay, everyone is going for option C here. Obviously, the angular momentum of electron in the hydrogen atom in the ground state matlab orbital number n equal to 1. Question is to find angular momentum. Formula क्या है? nh by 2 pi. N का value how much is it? 1. So 1 times h by 2 pi. That is it. H by 2 pi. So the angular momentum is what? H by 2 pi. That's the answer. Okay, I think you don't need any more time to copy this down or something. So it's very simple. Next. When an electron jumps from the 4th orbit to the 2nd orbit, what kind of width series we get here? We already have discussed the concept of this already, not a big deal, hai? So I know everyone is going to give me the answer within no time. Sahil, who is going to give me the answer? Elama, Sahil, Shweta, Khushi. Okay, everyone is going for the option B here, right? Option B bol raha hai. Okay, obviously, when any electron jumps from any higher orbit to n equal to 2, we get Balmer series, right? And what about the second line means? This is n equal to 2. If the electron jumps from n equal to 3 to 2, this is first line. Okay, if it jumps from 4 to 2, this is the second line in Balmer series. Okay, so if it moves from 5 to 2, that will be the third line of Balmer series. So keep this in mind how it is being numbered. Fine. Okay, so obviously our answer is option B for this particular question. Next one. Arey, I don't think you need explanation for this. Anyway, jaldi se give me the answer and we can jump to the next one. What will be the answer for this one? Answer क्या हो जाएगा? जल्दी 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 जल्दी. It's option B, right? Khushi B, Sahil B, yes. Then post your answers. It's very simple actually. Sumaya B, कुछ भी नहीं है ना? अरे यार, visible region Balmer series it is, isn't it? Yes. Okay. Here we go. This one, everyone try doing this. Everyone try doing this particular problem here, and I would love to get the answers from every one of you. Anyone? Sumaya, Intusri, Sahel. Everyone is with B. Is it B? B, check once again. B option. Oh, everyone is confirming it's B option. No other options you have? Okay. Let's see. I'll explain this question. Everybody listen. The shortest wavelength in Balmer series for hydrogen atom is A, and this is obtained substituting B in Balmer series formula. Here A and B refers to. Okay. So question is, right, obviously what is the wavelength of the shortest wavelength, and from where the electron has to jump to obtain this shortest wavelength. First thing we already have discussed. When electron jumps from any higher orbit to a lower orbit, energy is being released as photon. And how do you write the energy of photon? As h nu or hc by lambda. Right? Okay. Question is going for the one which has minimum or the shortest wavelength. The wavelength will be shorter when the energy of the photon released is maximum, because they are inversely proportional, right? And the energy of photon is equal to difference in energy of the orbit. So lesser wavelength is obtained when the difference in energy of the orbit is maximum. Okay, we know that the energy difference keeps on increasing as the electron transition happens from a very far away orbit, right? So tell me, in Balmer series, okay, in Balmer series, what can be the highest orbit which is a far away orbit, so that the energy can be maximum? From where it has to jump? It has to be jumping from the farthest orbit which is possible, and the farthest, okay, orbit which is possible is infinity orbit, because as long as the orbit is increasing, right, the difference in energy between them keeps on increasing. When the difference in energy increases, the wavelength decreases, and we are asked to find out the one with the shortest wavelength. Okay, so from where to where it has to jump? It has to jump from infinity to n equal to 2 to obtain the shortest wavelength in Balmer series. So formula for wavelength in that case, 1 by lambda is equal to r into 1 by 2 square minus 1 by infinity square. Rydberg constant 1.09 into 10 power 7. 1 by 2 square is 4 minus 1 by infinity square is 0. So 1 by lambda is this. So lambda is equal to 4 by 1.09 into 10 power minus 7. कितना मिल जाएगा? 364.6 nanometer मिल जाएगा. So which one can be our option? बता दे. Yes, the wavelength is 364.6 and n value will be infinity, because it has a jump from infinity to n equal to 2 to have the maximum energy or the shortest wavelength. Okay, complicated है ये. अरे ये तो कितना simple है, or at least I have explained you in one of the simplest way. What do you all say? You all agree with me? Even if the question is complicated, did I explain you in a very good manner so that you can understand the concepts here? Okay, yes, done Ameer sir. Okay, Sahil, easy question. Yeah, of course, because your way of teaching is crystal clear. ठीक है. ठीक है. So let us move to the last question of this particular 2-hour session, right? Okay. So here it is, that last question. Here we have. Which one? Which one? Which one? Which one? Jaldi se. Last question it is. So everyone, give your best, give your complete energy and give the answer for this question. I would love that. Khushi, Industry, Sumaya, Ria, Charan, Charan or Churan Baba. Okay. Sumaya, Sahil, everyone is going for option A. Let's see whether it is correct or not. In an hydrogen atom, which of the following transition would involve maximum energy? We know whenever electron transition happens, photon will be emitted. Energy of the photon is equal to the difference in energy of the orbit. Okay, so let's see among which transition the difference in energy of the orbit is maximum. So here we have the first orbit, second orbit, third orbit and the fourth orbit. So n equal to 1, 2, 3 and 4. Tell me what is the energy of the first orbit? That is minus 13.6 by n square, 1 square, because energy का formula क्या है? Energy of the nth orbit minus 13.6 by n square. Okay, for the second it is minus 13.6 2 square. For the second orbit, n takes 2. 13.6 by 2 square is 13.6 divided by 4. 4 and 13, 3 minus 3.2. Okay. For the third orbit, minus 13.6 by 3 square, that is 9. So this will almost come around minus 1.5. Next is minus 13.6 by fourth orbit is कितना आ जाएगा? 4 4 16. 13 by 16 almost 0.8 it comes, I suppose, approximately. I'm just writing it. Okay. Now let's see. Okay, what are the energy that is being released during the electronic transition? First case, when electron moves from 2 to 1. 2 to 1, energy that is being released is difference in energy. Minus 3.2 minus 13.6, if you find out the difference, कितना हो जाएगा? 10 point. This much is the energy difference. Okay. When it is moving from 3 to 1, how much is it? Array 1.5 and 13.6, how much is it? 13.1 and 12.1, I suppose. Array wow. So here the difference in energy is almost 12.1. Then 4 to 2. Here 4 hai, 2 hai. Okay, 0.8 and 3.2, almost 2.4 or something. Difference in energy. And from 3 to 2, 1.5, 3.2, 1.7. This much is the energy difference between the orbits. Tell me which is having the maximum energy difference here when the electron jumps from 3 to 1. Right? So obviously it is this energy electronic transition has the maximum energy release when it jumps from 3 to 1. 3 to 1, option B, that is the correct answer for us. Okay. आ गया समझ? Are all the questions clear to you? Riya, Sumayya, Sahil. Everyone, bye bye. Okay, thank you so much, Elma. Yes, everyone. Okay, so yes, you all know this is the time to show some love towards your bhaiya. So before leaving, don't forget to move your cursor and click on the like button. Okay, because all the likes in the classes will let me know how much you have enjoyed the class and how much like you all have for your Ameer bhaiya, है ना? कोई बात नहीं, Sahil, Riya, thank you so much for being here and for all the compliments. I know that you would love to have so much of scholarships when you join your colleges, right? So if you would love to have a college scholarship worth rupees almost 20 lakhs, you can be a part of Unacademy Prodigy exam. The last day of Prodigy exam is Feb 27, which is tomorrow. You can come and write from 12 to 1 p.m. and it is completely free. You can just use a code of AMB10 for enrolling to this Prodigy program for free. Okay. So this is for class 11th batches. Class 12 batches are here. You can be a part of any of those and enjoy being a part of it. Special class timetable, I think my special class here in this Unacademy is almost over. As you all know, this is my last month here in this with Unacademy, right? Okay, special class amazing features is what you can see it on the screen. So offers are going on. If you go for 3 months, 1 month is given extra free. You can use a code of AMB10 to get 10% of extra discount. Okay, fine. So thank you so much, everyone. Don't forget to like the class and share it with all your friends. ठीक है ना? I think you all are gonna do that. Jaldi se now itself you all can do in all your groups and all your classes. You can just share the class. Okay, so yes, bye everyone. Riya, Sahil, Sana, the other regular Sahil, बाबा भैया, सुमैया, मजा आ गया? तो बिल्कुल बढ़िया बात है, मजा आ गया तो. Song on song nahi. Okay, I'm really sorry. Song on the very last class, which means Monday's class. Fine. Okay. So bye everyone. See you all. Till then, take care. Bye bye.